Hello, welcome back to my series where we're sort of making a Pokemon battle system in Godot, focusing on the data flow of it. This is the last main video in this series, but please stick around until the end where we'll talk about what I plan for the future of this series. It's not the end of everything, but it will be the end for now at least. I hope you've gotten something out of this series so far. This is the first learning content of such a big magnitude and scope that I've made, and I've learned a lot of video production techniques and teaching techniques and even a bit of GD script as I went. So I'd love any feedback you can give me. Toss it in the comments. Anything positive, negative, whatever. It will help me grow, and it will probably be good for my algorithm too, or whatever. So there are a few things I want to handle before we finish. The first one is to handle monsters learning and swapping out moves. That's going to be the majority of this video, and it's one of the more interesting problems I solved, so it'll be fun. The second will be a little bit of UI work to make the health bars mostly animate a bit nicer. And then the last thing is I want to leave you with an idea of where you can take this from here. What kind of functionality you could add, what kind of graphics you could add. Really, the only limit is your imagination. Great, let's handle monsters learning moves on level up. Until now, we've just had monster species initialized with a set of moves on each monster, but moves are actually not something that should be derived directly from the species. They're particular to a monster. What species have are a set of moves that they are born with and a set of moves that they'll learn at particular levels. Individual monsters start with some moves from the species, but can learn moves as they grow and also through other sources like items, which we aren't going to implement, though you can. It won't be hard. Anyways, let's have a look at species. Basically, what I want to do is add an array that associates moves with levels. We could do this with a dictionary, I guess, but then we'd be limited to one move per level. So instead, for more flexibility, we're going to create a new resource to hold this level and move structure. We'll call it int move resource. It's going to extend resource, and it needs a class name. We'll have an int, and I'll call it I to keep this generic for now, and then we can have a move resource too. Actually, let's call that integer just to make it more clear for the future. Now in species resource, we'll create a new array for these. Export var learn moves, an array of int move resources. And let's add some to salamander. I think in my starter state now, salamander starts at level 4, so let's make sure we start at a level that gets the moves we add. Make sure you add move resources that you already have. Don't create new ones local to this, or else they won't update when you change them. Let's go to monster controller and find level up. And how do we figure out what moves we can learn? Well, let's make an array called moves to learn. From monster.species learn moves, we'll filter, and we want to filter on the move level being equal to the level we just got. And since we level up one by one, we don't need to check less than here. So it doesn't like that because we need monster.level. Okay, now we need to add these to something, but what? Let's go to monster. We want a const for max moves. So 4 is the traditional value in Pokemon, but you can do whatever you want, or you can make it unlimited. And back in monster controller, while moves is less than max moves, we can start adding moves. And we're going to deal with replacing moves later once you're at a max. So we can make a var for more to learn, and we'll pop front, and we can append. But first, let's make it an actual move entry with move.new. And then move resource is our resource. And we want to max out its usages, and we can append it to the list. And let's make sure the experience value is very high and see what happens when we run the game. There's a bug. We need to check if there is anything in moves to learn. If moves to learn is 0 or less, return. And now it gets here. We also need to check this in the while loop. Let's add that here instead. And now when we level up, we learn regenerate, which is correct. Let's add a quick log for this too. We'll do avfxmanager.quavfx message with the monster name has learned move name. And we can add the values in, and it should work fine. Let's check. George gets to level 5, George learns the move, and yeah, we can deal with move management next and the possibility that we already have max moves and need to replace one. Okay, let's deal with replacing moves. This is one of the harder tasks, and I tried a few ways to do it, but where I landed on requires that we make some UI changes. Basically, I want to make a special kind of message that gives you options, often something like yes or no. We can give arbitrary options though, and then we can use our existing UI with that in order to let people prompt if they want to change a move or not. So we're going to have to move towards that first. So let's see. I'm going to call avfx messages here. It takes in an array of string. I'm going to create a new message resource because messages are not going to be represented by simple strings now. We can store them in resources, but we can also make them on the fly. What does it get? Well, it needs some sort of text variable like a string, and it also needs choices. So choices are going to be an array of something, and we'll call that choice resource. Let's make a new resource for choice resource. Each choice resource stores an export var text, which is a string, and an export var of, well, I guess it should be some sort of function that gets called when you select this choice. So callable is the type for this. We'll do a simple example of this first before we figure out level ups. Since we're making these from script, we'll add an init here, and we can use init to override the constructor function like choiceResource.new and give it some args, text, a string, and a function callable. And we just need to bind these args to our member variables. Let's add a similar init to message resource. text equals text, and choices equals choice. This is going to require us to redo a bunch of code to support it, but I think that it's going to be worth it because then it will make things quite a bit clearer and much more reusable. Let's hook this up. So in message panel, we'll see that message queue is an array of string. We have to move this to be an array of our new message resource type. And in AVFX messages is going to be a message resource. Now this is not going to be ergonomic for some of our use cases that just want strings, which will be a lot of them. So we should add a function for that in the future so we can just support passing in string arrays. We're going to have a bunch of problems now. In message panel, current message shouldn't check for an empty string. It should instead check for null and default to null, and it should be a message resource. And in show message, we've got labeled populate here. We need to populate from message.text instead. Then we'll need to display its multiple choices. In 2D view, let's look at our message panel, and I'm going to add a VBox container called layout. And I'm going to make typeout label a child of it. And I'm going to make an HBox container as a second child of it called choices. And then here we can just put each of the buttons for each choice. So let's add these choice buttons. So we can go export var choice parent, which is a control. We're just using it as a node for hierarchy. And we'll link that up to our message panel node. First, let's give typeout a minimum size in layout. 200 is fine, I guess, but you can do whatever you want. And back to choices. It needs to be referenced in our message panel script. First, we need to clear out any old choices. For child and choice parent.getChildren, queue free. Then for choice and current message choices, we'll do var button equals button new, choice parent.add child button, and button.text equals choice text. And then we'll connect up the function with button.press.connect choice.function. I think that will work, and we can move forward with this. We might need to add something later to dismiss the panel based on this, but we'll burn that bridge when we get to it. Now let's run to see what else breaks. So QAVFX message is giving a string, and it should be giving message resources. You know what? Let's keep this as an option. We might want to generate messages from just a string, but expand this to let us pass in choices also and default to an empty array. We need to change message here into a message resource, and we'll use the constructor we made with init to pass in message and choices. Now we can just pass that into this array here, and that should work. Let's find our next problem. So in Monster Controller, we're passing in a big array of strings. How should we fix this? Basically, let's give ourselves a convenience method where we can pass in strings to create messages. So in AVFX messages, let's make a static func from strings, and it takes in an array of strings. It should just return a new AVFX message resource based on the strings we pass in. We'll just loop through these with a for loop and create a new message resource for each and add it to the AVFX message resource. Then we just need to return messages resource, and this should let us use our old interface for this. Back in Monster Controller, let's swap it to use from strings here. And if we run the game, we hit the same issue and use item. So swap that to from strings and play again. And it runs, but it doesn't really work. So we're getting error calling from signal on AVFX messages in queue messages. I don't think we actually need that. It's not used anymore. Okay, now let's see. We have an error in request log since we changed what type it gets. So log expects string text, but we're not giving it that anymore. All we have to do is change the argument that request log.emit gets to just message text, and that should fix it. And that looks better. There's no more errors. Let's move on. So let's do a really easy trial run to take advantage of our new dialogue choices. In handle run, we're going to enqueue a message that will show up when they run away from the battle that asks them, "Are you sure?" and gives them a yes or no option. So let's go to handle run, and we can get rid of all this timer nonsense and then create our two choices. So choice run is going to be a choice resource.new. Leave, and we can pass in the handle quit function from below there. Awesome. And then choice cancel, we'll do choice resource.new cancel, and I think we can just do a no op here. So we'll do a lambda that just returns a no op, a noop. Then we can change the message to have an if you run away and pass in our two choices. I think this should work. Play, run, and something's not working. In message panel, we're checking an input event. We need to make sure it's only being checked if there are no choices, and if we don't, dismiss choice dialogues without a choice. So we'll do play, run. Okay, quit works, but cancel doesn't. We need to add something to make it so that anytime something is selected, the dialogue dismisses. We'll make a do choice function in message panel. Choice call, dismiss message. And make sure that's hooked up to button.pressed. Now let's try it out and see if it dismisses. And it does. Perfect. We now have a working choice menu. But how do we deal with replacing moves? This is definitely one of the harder things, and I'm going to take a breath and we can get into this. I'll close up the scripts we've got open and open up Monster Controller and Monster. I think we want to store moves that have not been learned yet, but are in queue to be learned in some ephemeral state in the monster data object. These will be anything that you have just leveled up into and haven't had a chance to select or refuse. I'm going to find our level up code, and let's see. I think what we want to do is put all of the moves that we need to make decisions on in this queue. So pending moves queue will be an array of move resource. And then what we want to do is in level up monster for move to learn in moves to learn, monster.pending moves queue append move to learn. So move to learn is actually of our integer move type, so we can just pull the move off of that. We don't need the level anymore. Now we can remove this check for greater than 0 since we've got to do this elsewhere and asynchronously, and update this to pop front from the pending moves queue. We'll have to check for something. We can change this usages set to move resource usage max, and great, I think that works fine. Now we have to capture the case where we might have to replace something. So let's do that. Up here, after we do the level up chain here, we'll call it maybe give move replace choice, which takes a monster as an argument. How do we know if we want to give a trainer a move replace choice? Well, that's if the current monster has anything in its pending moves queue. So we'll check that here. And if there's nothing, we can just return. Otherwise, let's grab the first move with pop front. Now what? Let's check if monster is the current player monster. I'm only going to support move management for the player monster for now, but you can make the enemy choose random moves or whatever yourself. There's some complications there, so let's ignore it for now. Now let's create one of our choice messages here. The string will be monster name wants to learn move name, replace move. And let's create two choices. Choice yes gets a label and a func. We'll come back to what we do with this function. And then choice no gets a label and a func too, and I think this is basically a no op also, so we can just maybe just send a message. Okay. So adding a to do here, but let's check if this shows up. And let's do a format for that string too, so that it takes in the monster name and move name properly. Let's make sure this actually happens. We're going back to Salamander and content, adding 2 more moves to him, torch and smack. It doesn't really matter. And we just want him to be full. Let's see what happens when we play and level him up. Nothing. What are we missing? We are calling our maybe give move choices function, right? Okay, let's set a debugger. Okay, we have moves to learn, 1, which is regenerate, and heading down here, it looks like we're not actually sending this choice at all. Oops. Okay, adding a call to AVFX Manager with our choices and testing it. We get our dialogue. Yes just dismisses, but that's because we haven't finished that function yet. What do we do with this though? Well, I wonder if we can just reuse some stuff since we've already got our option panel that lays out all our current moves. I did some thinking and it got a little hairy, so I decided to just duplicate it with a new functionality. So in our controls menu in Battle Renderer left, we'll add a child and we'll do option panel, and we're going to rename this to move select panel. It's showing there because this is tiny. And if we select move select here, there are options for mode and options parent. So let's add a child node. It'll be a VBox called options. This needs to be assigned to the options parent. And then for mode, none of these are correct because we want a new mode that sends a new type of signal. Let me show you. So if we go to script and look up game runner, you'll see we capture all of our menu options here. Mon, fight, run, or item, but we have another one now, so I'm going to add one for move replace. I ended up having to restart Godot here to make it show up. Sometimes this happens, but here it is now. Excellent. This will work exactly the same as the option menus, except that it will send the signal with the move replace value. In our match statement and handle request menu option, we can just add a new clause for move replace. And I think we want to do something on monster controller, like set monster move at index to pending move with gamestate.playerMonster and index. Of course, we need to make this function now. So let's go to monster controller and we'll put it with these other ones with the args we set, monster and index. And let's just return for now so we can come back to this. We need to store the move of the monster that is currently being dealt with. So let's deal with that. And maybe move replace choice, we are storing it to a local var here, but let's put it on the monster itself. We'll create some more ephemeral state called pending move. Now we can store this and we can do monster.pending move, and we already know the monster, so all we have to do is switch them. I'm going to store the previous move so we can refer to it in our success message. You can do other things with it too. I don't know what, but it's there for you. And we'll do move equals move.new and set the resource and usages for the new move here. And we could probably find a better way to do this, but this works for now. And we can add this to the monster moves, and then we want to clear monster.pending move. We'll queue an AVFX message with a string that says the monster forgot the old move and learned the new one. And don't forget to format it using the monster name and the move names. Of course, none of this is going to be sent since it's not connected yet. We're never giving our new select panel any labels, and we're not calling it yet, so let's figure that out. If you don't remember how to do this, we did this, I think, in the first and second videos in the series, so you can refresh yourself on that if you want. So I think we want to control this from the battle renderer. I'm going to give it an expert var for move replace panel of type option panel. We'll assign it, and back in script, here we are. Well, what do we need? I think we need some events to summon this, and let's look at that. We need an event that says that the move is pending. on player pending learn move, and an event that says that the learn move has been resolved. On player move, replace completed. So what do we do with these events? Let's connect them here. So we'll do events on player learn move.connect, show learn move panel, and events on player move replace completed, hide learn move panel. These aren't real functions yet, so let's make them. Okay. We want to show the move replace panel and hide the other panels here. And the other, we want to hide the move replace panel and probably go back to showing controls. By default, I think messages will take over otherwise. And let's make sure that whenever any other panel comes up, we'll hide this one too. Just follow the same pattern here. Okay, so labels. For our other nodes, we pass in labels that are in these string-enabled objects through populate. We can do that and make sure that show learn move panel gets an array of string-enabled, and we can pass in as labels. Okay, so on player pending learn move isn't emitted anywhere yet, but in monster controller, the change should be here, right? We need to actually send that function in our choice yes var. So let's emit that here. We'll need a labels array ahead of time. It will be a array of string enabled for each of the current moves, and the enabled can be true for any of them unless they aren't able to unlearn a certain move, like I guess an HM in the old Pokemon games. But we won't handle that here. It's easy enough to change if you want that. Let's loop through them here and give them all true, and then we can just summon that menu for us. The last thing we need to do before we can test this is hook up our finished event here. So where does that go? I think just in that monster controller in set monster move at index, and that should work for now. And the last thing we need to do is call this again, just in case the monster has a second move in queue. I'm going to play it and see if it works. There might be an error, but okay, it didn't work. And why is that? Let's see if show move learn panel is getting called. Yeah. We've got labels. That's good. We're populating it and down, down, down. Okay. Now, what would cause us to get hidden? If we hit this, let's see if our completed gets hit, hiding it. Nope. Looking at remote here, move select isn't even visible. After some poking, I find that in do choice, in message panel, we need to dismiss message first, otherwise we dismiss the next message too. Oops. Now it works. And then the last thing in this part I want to do is look at this outcome panel here where it says that you win or lose. I want to move this to be a message with options too, just for consistency and simplicity. So let's go to script and resolve round here. I want to make a new AVFX message for this. We'll still emit this, but we won't connect to it right now. And we'll queue a new AVFX message. You lose, and the choices will be quit and restart. We'll pre-make the choices for this up here, and quit choice, we'll say quit, and we'll just handle quit. And restart, we'll say restart, and we can just call handle restart. This should be fine. Now pass in quit choice and restart choices here, and we can reuse this for the you win outcome too. And then we can remove the outcome panel from the UI. We'll have a look at it here, and we can just delete it and see what happens. I'm going to remove the second enemy monster from our start state so we can just test a win real quick. So you win, quit, restart, and I think that works. Outcome panel is deleted, so let's delete the code for it too, and that should be much cleaner. So I'm going to prefix all of our choices with little angle brackets, like little arrows. I think it's got a little bit of an authentic feel, and yeah, that's good. You can handle AI move selection if you want. I don't think Pokemon games do that. I think they just give their AI monsters whatever moves, but it's easy to do that. Okay, that's enough for that section. On to the next thing. Okay, let's do a little more work on the UI. We're not going to fix everything. There's actually a few issues, but I want to give you some patterns to improve how the UI responds to model changes. Let's look at our HP bar. So when damage happens in the model, it updates instantly. And yeah, whenever we emit on monster updated, not after the actual damage animation happens, and this looks a little bad. So it's going to be hard to have perfect control over this. You'll have to do that on a like move by move basis, I guess, but we can improve it a bit here. So for now, let's only call on monster updated at the end of GameRunner.resolve round, and only after all of our AVFX have been resolved. So if I call it like this, with GameState.OpponentMonster and also play a monster, this is going to be a problem because it will be called immediately whenever moves are selected. But at least we can remove all of the other calls to it throughout the project. Let's search up on monster updated and erase them all. So So if we play this again, it should still preemptively update because we're not asyncing this, but it's cleaner at least. I'm going to give some quick animations to this Poison Sting move for Salamander so that we show an animation here. Just a quick move from left to right to look like he's attacking, and an enemy flash, and a small delay here to make sure it happens after the movement. Okay, that looks a bit better. And I'll give Dino some more health so that he doesn't die instantly every time. And back to the UI. As you see, the UI bar still disappears instantly, and we don't want that. Let's do a thing. I'm going to add a new AVFX, and it's going to be just a generic AVFX that lets us bind any arbitrary function that we can call when it runs. So I'll call it AVFX function, and it will extend AVFX resource. And what does it need? Well, let's look at other AVFX resources. It just needs a do function and a function that is of type callable. We'll have to bind this when we create it. And on do, we do, well, let's see. We aren't respecting delay yet, so we'll have to figure that out. But basically for now, let's just do function.call, and let's see if this works here. And here we can do AVFX manager.QAVFX group. And what is it going to be? Well, we can just give a series of AVFX resources. We'll give it 2, update player and update monster. And the callable will just be a func that emits the signal we want. Now this won't run until after all the AVFX works, which will handle most of what we need. Now it doesn't run until both turns go, which isn't quite what we want. We want each move to happen, then update, one after the other. So let's do a version of this where we bind it at the end of a move's AVFX. Let's look in our methods here, use monster move, and we should make a new AVFX group here so that it's queued to run after the others are finished. And this is also a problem because logs weren't getting sent from here. We need to move it up because these effects also add logs. Next, we want var, and after the other AVFX group, so it runs after. Var cleanup AVFX group, it will be an array, and we will make a var update effect that's an AVFX function with events on monster updated dot emit. And it's going to be the monster that's in the context of this function. Then we want to queue AVFX group, update effect. Now this isn't very granular. If you've got a move that does multiple parts, like a multi-attack, it won't do each one. You'd have to make this respond multiple times throughout the model for that, and maybe add at the end of the damage AVFX. Let's keep this emit on resolve turn too, just in case we miss something so the UI can catch up. Now let's test it, and it looks okay, but it's timing out and not cleaning up properly. So let's go to our do function in AVFX function, and we want to make sure we run instance.finish. Now let's deal with delay. We should probably follow the same old patterns and emit an event that we catch and trigger, actually. That way we can handle delay in a more usual way. Because we can't just add a timer to our resource. I'm going to catch it from Game Runner here because it's generic, but you can put it elsewhere. I'm going to catch it from Game Runner here because it's kind of generic, but you can put it elsewhere. Events on AVFX function, connect, handle AVFX function. And we need to make a function for this. We'll put it down near the bottom. It gets an instance, and we can give it a callable function just for convenience. And then we can use the same pattern we use elsewhere, like on AVFX SFX. Let's find how that does a timer. We'll grab that and drop it into the handle function. And update it to use our function. I'm going to use function.call, and here we want to on timeout function call. And it doesn't have to be a lambda here. Now all we need to do is emit this from the resource. Now hopefully it will respect our delay. I don't know how often it's going to use that part of it, but we'll suppress this for 1 second and see. We'll give this one delay. Now hopefully it will respect our delay. I don't know how often you're going to want to use the delay part for this, but let's try. We'll give it a delay for a second, and we'll see how this looks. Now this means the HP probably won't update for 2 seconds, and that looks okay. Okay, so rather slow. Oh yeah, okay, so we want to make sure that we add an emit for the target also here in case it's an effect that does something to both of them. So, yeah, the variable's called opponent here. Okay. Now we don't want to use the delay right now. I just want to test it, and I'll remove it and see if things look a little better. It's now timing out again because we need to resolve the instance in Game Runner. And we have to function call and then do the instance, so I'm going to have to make a function for this. Call AVFX function. And then we do function call and instance finish. And call that handler from a lambda here, and make sure that the non-delayed version also does this. Okay, that's a little better. It doesn't update instantly now, and yeah, you might have to tweak this to make it call and update when you want to, but now you have that power. Fantastic. Well, it's not perfect, but it sort of works. There are obviously a lot of things missing here still. There's some glitchy behavior with the AVFX targeting code that might get better if you target by trainer rather than monster. There's also a lot of functionality missing, monster catching, same type attack bonus, and a whole overworld, and any other modes of play you want to incorporate, but maybe you can figure that out. I do intend to come back and add some stuff to improve the architecture of the game, especially in the context of adding another mode of play, like an overworld. So I would probably look into working on our events mega class and splitting that out into kind of more appropriate encapsulated signals, and also breaking down some of these singletons and thinking of ways that we can smartly pass them to things that need them. This is not super important with a small contained prototype with a single sort of mode of play, but when you want to mix and transition between different scenes or types of game, we can really benefit from a bit better management of our big controller classes. Anyways, this course is getting very long, and my promise was to show you how to set up a battle system like this, and I think I kind of have. So sadly, this is where the tutorial ends. We can add more content, we could polish a lot of things, and there are bugs, but now they're your bugs. So take this, make it your game. Here are some ideas. 1, we've built a system that has a very strong separation between the presentation layer, the AVFX, the sprites, the UI, and the data layer. It would not require many changes at all to slot in a different presentation layer with nicer sprites or 3D graphics or anything you want there. Get wild. We haven't really touched an overworld, but I believe most of the concepts that we've discussed of the series will be applicable. Use the data classes and resource classes, use signals and state machines. You'll need a bunch of new UI elements, and maybe you need to integrate a Godot tile map, but I think you can figure that out. Because of how we've locked our data management to a single isolated part of the game and set up things to use a single deterministic RNG seed, it shouldn't be too hard to think about passing data for multiple players, for multiplayer. It will require a bit of re-architecting, and I don't know if I will get to that with this or not, but I do think because of how we have set up our data, it wouldn't be that crazy to shift towards that. Or you could just take these concepts presented here and run, make your own game from scratch, make it big, get it done. As I mentioned at the beginning, feel free to use this code to build your own game, and certainly use the ideas here. That's why I taught them. I'm likely going to be revisiting this code again in a few months' time, maybe, to go over kind of architecture concerns for slotting in a overworld adventure mode, but I won't be building that whole mode itself. That'll be for you. I'll just kind of show some of the improvements we could make to make that fit together. So please comment any lingering questions you've got or things you'd like me to cover next. If there's enough interest, I will make other follow-ups, and we can play around with this some more if you want. Anyways, I am making more videos on Godot and indie development, solo development, and like data-driven games, so please subscribe, and I will see you soon. Goodbye.